In this problem, what we're working with is, once again, balancing chemical equations as well as the solubility rules. We're going to be looking at a balanced equation, a total ionic equation, and then the net ionic equation. So the first problem reads as such, or the problem reads as such. There's two parts, there's two separate parts to this. Which of the following pairs of aqueous solutions is mixed? Does a precipitation reaction occur? If so, write the balanced molecular, total ionic, and net ionic equations for each of the following. So the first one we have is we have potassium chloride and iron 3 nitrate. So we have potassium chloride, which is aqueous, plus iron 3 nitrate. So that means that the iron has a +3 charge, the nitrate has a -1 charge. And if we're going to write the balanced equation for this, the iron is going to go with the chloride. This is +3, that's -1. So it becomes FeCl3. And going back to your solubility rules, this is going to be soluble. Plus, we have KNO3 aqueous. Now, if we wanted to balance this, we'd put a 3 here and a 3 here, and that would be balanced. However, this is not a reaction. Nothing actually occurs here. This is aqueous, this is aqueous, this is aqueous, this is aqueous. So all the ions are just floating around in solution. They're not doing anything, and so this is a no reaction. So for A, there is no reaction. For B, it says we have ammonium sulfate and barium chloride. So if we have ammonium sulfate, this was A, this would be B. We have ammonium sulfate. Ammonium is going to be a +1 ion. The sulfate is a -2 ion. This is aqueous. Plus barium chloride, and that's aqueous. And the products of this now is going to be, the barium is going to go with the sulfate, the chloride is going to go with the ammonium. And so we have ammonium chloride. Ammonium is +1, chloride is -1, so the ratio here is 1 to 1. And this is aqueous. All ammonium salts are soluble in water. And then the barium is +2, the sulfate is -2, so this becomes BaSO4. And working off our solubility rules, this is going to be a solid. Now a chemical reaction occurs because we have something in a different phase. Here in A, they're all aqueous, 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 aqueous. We didn't have a change in phase, and so there's no reaction. If we want to balance this, we have to put a 2 there, and I think that's all we have to do. Yeah, we have 2 ammonium, 1 sulfate, 1 barium, 2 chlorides, 2 chlorides. Now it's balanced. Now we have to write the total ionic. So for the total, we have to write this total ionic. We have 2 ammonium plus 1 sulfate plus 1 barium plus 2 chloride. All right, so that's the reactant side. They're all going to be aqueous. On the product side, what we have is we have 2 ammonium plus 2 chloride plus, now this is insoluble in water, thus the solid. And so this just becomes barium sulfate solid. So now this becomes the total. Now the net ionic, I'll use yellow. For the net ionic, basically all you do is you only work with the compounds or the ions that actually produce the product that is insoluble. So this is the only one that's insoluble. And so we're only going to be working with the barium and the sulfate. Now another way to think about this is we have 2 ammonium, they're going to cancel. We have 2 chlorides, they're going to cancel. So all we have left is the barium salt, the sulfate salt, and then it's going to produce the insoluble or the precipitate barium sulfate product. And so for the net ionic, it's going to be the barium 2 plus aqueous plus the sulfate, which is aqueous, which is now going to produce the barium sulfate precipitate. All right. So hopefully you've seen what I've done. For the net ionic, you're only going to work with with the ions that produce the precipitate. And so you don't worry about the ammonium or the chloride because they're what are called spectator ions. So those two, they're simply the spectator ions. They do not participate in the reaction. They spectate or they watch the barium reacting with the sulfate to produce the barium sulfate. And once again, in A, this is not a reaction because everything is in the aqueous state, nothing changes, nothing happens. If you have any questions on this or any other problems or topics in this chapter, please let me know.